Good morning students, myself Badi Alekhya, Assistant Professor, Artificial Intelligence and Machine Learning Department, RMD Engineering College. Today we are going to discuss one of the important concepts in third unit, CNF problems, so class normal form problems. So before going to solve the problems, you have a knowledge regarding that how proportional logic predicates will be right and first order logic predicates will be right. Then only it will be easy to solve the problems under CNF. So just to give a brief revise regarding to proportional logic and first order logic. When we are writing proportional logic is a Boolean logic, we can conclude the statement is whether the given statement is true or false, and we are using some logical connectivities to implement the statements which is coming in combination, or if either or if then and if only if. Some of the logical connectivities you remember that and or negation, if then and if and only if statements. And under a first order logic you have to remember two types of qualifiers, how to implement it. For representing all we are using universal quantifiers. For representing something we are using existential quantifiers. So if you have knowledge regarding how we are writing the predicates by using this universal quantifiers, existential quantifiers and proportional logical connectivities, then will be easy to implement CNF rules to the given predicate logics, and you can conclude the statements for the following sentences. So let us start with the example. Here Marcus was a man. So it's in mission it can be represented by predicates, it can be represented by man of Marcus. So these rules mostly we are going to write in a real time tool called prologue. So same thing, if Marcus was a Popine, now you tell so Popine of Marcus. So born, the keyword we have to consider this predicate. These born, Pepine, man, these and all we call it as predicates. All mortal, all man or mortal. Now you observe these symbols. These symbol, the zeros with the underline will represent for all. So all mans are mortal. Now here we are representing all males. If the all mans are mortal, now if there is all the mans who, if the category belongs to man, then they are all mortal. Then if then will be represented by using this symbol implies. For all will be represented by using symbol or. So in this way we are going to write the predicate logic, and we can also construct the proof tree. By combining all this statement we can conclude that whether Marcus is dead now or not. In different way we can provide assumptions, and we conclude that whether the Marcus is dead or alive. So this is the statements how we can take the right path. We can either implement by using tabular column. So here we in this by conclusion we can say is that the Marcus is not alive. By all the steps if you are going to conclude, in the last step we can prove that the in this yes the Marcus is not alive by using some truth statements. Already we discussed that the proportional logic will be concluded that the whether given statement is true or false. So now come to the second example. It will be helpful for you people to how to solve the CNF problems. So same things, but in a different way. How to constant will be constants are Marcus and Caesar. These are the two persons we are constantly used in this particular examples. And what are the predicates for supporting these two constants are peoples, Popine. So man, mistakenly typed as people, is a man of X, Popine of X, Roman of X, Roman of X, and rulers of X. These are all the some of the predicates supported by the given example. uh, See if I analogize this thing and I will show. So already you know man of Marcus how it is a proportional logic. So Marcus was a Popine. So all Popines or Romans means it's represented in if then else, and all will be represented by using this symbol. And these are this loyal or hate. At that scenario we are using logical connectivity. Or if we are representing something as loyal and something as all are loyal or something as another variable, if you represent these two things now, for these symbol will representing all, and these among that we are considering only some. Among all we are going to consider only some now. At that time we are using both type of quantifiers. The name of these two symbols we are called it as quantifiers. The first symbol will represent universal, that represented all, and the second symbol with represented there exist. So in this way we are going to design the predicate rules, and how these statements will be converted into CF forms now. For example, if these are all simple statements, here we are not going to apply any CNF rules. If the statement is in the form of A implies B, if you are observing the statement 3, the statement 3 is in the form of A implies B. So these A implies B, if when you are going to apply a CNF rule, these quantifiers will be removed. Clearly listen that this quantifier will be removed, and this popine of x will be converted. This is in the form of A implies B. This A will be converted into negation of A. So sorry, negation of x. That means here then the A plus popine is there. Therefore, in front of popine we have to apply negation symbol, and implies will be converted into R and the Roman of x. So remember this formula. If the your predicate logic is in the form of A implies B, before A implies B, any universal quantifiers or existential quantifiers, you have to remove that quantifiers, and you can replace these A by negation A and B by as it is B only. That implies is going to convert into R. So the simple formula to convert the given for predicates into CNF form is, if the predicate is in the form of A implies B, the CNF will convert that predicate form into CNF form by applying the formula A implies B. We are going to apply that A will be converted into negation A, that implies will be converted into R, and then B as it is. So the formula for is, if it is in the form of A implies B, you have to convert into negation A or B. So same formulas you are going to apply for all. If any existing qualifiers or universal quantifiers are there, eliminated and implement the problem. So next move to the next slide. If you see, observe here, we are going to consider the what we have to prove, hate of Marcus comma Caesar. That means we have to conclude that Marcus hate Caesar. How we are going to convert Marcus hate Caesar now? We have to consider the negative terms, and you have to consider with the cancel with the positive terms, and we can conclude that Marcus hate Caesar. So again the given form here, if you are kind to try to assassinate Marcus comma Caesar now. Here we are going Marcus assassinate try to Caesar. The negation will be converted into A. So the negation will be converted into A now. Marcus try assassinate imply that sorry these things will be converted into implication and cease, and concludes that Marcus hate Caesar. So so contradicting terms will be cancelled, and we can prove that our statement Marcus hate Caesar. So I think so it will be cleared for you people how the contradiction will be implemented for the given problem, and how we are going to apply the CNF rules. Thank you all, and we will meet with the new concepts in the next session.